Welcome back to Best Academic TV. In this video, we're going to focus on Newton's second law of motion. And this is question 3 under Newton's second law of motion, okay? So let's solve this question here. But before we solve this question here, let's understand what the question is. They said a body of mass, the mass given to us here is 5 kg, a body of mass 5 kg, initially at rest. When an object starts from rest or an object is at rest, we say that u initial velocity is equal to 0. Please take note. A body of mass 5 kg initially at rest is acted upon by two mutually perpendicular forces, 12 newtons and 5 newtons, as shown below. If the particle moves in the direction OA, calculate the magnitude of the acceleration. So this is the question here, and the diagram is given to us. All right, this is the diagram here. Okay, so we are given this part to be 12 newtons. This part and this side here is in the same. Please take note. So this is also 12 newtons, and we are asked to find the acceleration between these 12 newtons and 5 newtons. For us to find the aggregate acceleration between these 12 newtons and these 5 newtons, we have to apply Pythagoras theory. Please take note. To find the force that will be acting on this side here, that is the net force that will be acting on this part here. Please take note. So is the acceleration on this part O, the acceleration on this part here OA. We are asked to calculate OA. Remember? And the force OA here can be calculated using Pythagoras theorem. Okay, so now let's apply Pythagoras theorem here. So we say the square on the hypotenuse is equal to the sum of the two square in a right angle triangle. Please take note. So this will be 12 squared plus 5 squared. Okay, let's simplify this class. So I'll have this will be f square n is equal to 12 squared is 144 plus 5 squared simply means 5 times 5, which is 25. Please take note. So let's plus up this guy. So this plus this will give us f squared is equal to 169. But we are not asked to find the acceleration of f squared. We're asked to find the acceleration of f. So f only will be equal to plus square root of 169. And when you punch your calculator, the answer is 13 Newton. So the force along this OA, is given to us as 13 Newton. So, but if you look into the question here, we are asked to find the acceleration along OA. We are asked to find acceleration along OA. So how do we find acceleration along OA? Let's list out the given parameters here. Okay, from this, the given parameters here, mass is given to us as 5 kg. The force along OA is given to us as 13 newtons. And we are asked to find A. So class, in case you have not watched most of our videos on Newton's second law of motion, all you have to do is to watch the videos to get most of the formulas related to Newton's second law of motion, okay? But the first formula related to Newton's second law from the statement of the law is this. The first formula related to Newton's second law of motion is this: F is equal to m into v minus u over t. This is the first formula here. The second formula here is F is equal to ma. This is the second formula. The third formula here is impulse is equal to ft, or impulse is equal to m into v minus u. So these formulas are derived from this fundamental formula. The equation of motion, we say that A is equal to v minus u over t. Okay, when you replace that, you have this. Now, when you make ft, the solid of formula here, you cross multiply here. This is ft. I will have this to be ft is the same as impulse. If you're asked to calculate impulse when force and time is given to us, you can use this. If you're asked to calculate impulse when there is change in momentum, you can also use this technique, okay? But in the given parameters here, in this question we are solving, we are given force, we are given mass, and we are asked to calculate this acceleration here. So equation 2 we work at in this particular question. Now using equation 2, so using equation 2 here, let's replace this. Force is given to us as 13, mass is given to us as 5 times A. So let's make A the sort of formula here. So I will have this to the class 13 is equal to 5A. So in mathematics, if you have something like this class, if you have something like this in mathematics, 2 is equal to S. Is the same thing as S is equal to 2. Please take note. So this is the same thing as 5. This is the same thing as 5A is equal to 13. Let's make A the subject. A will be equal to 13 over 5. So when you punch your calculator, we'll have this will be 2.6 in meter per second square. This is my answer here, okay? What you have to do here to get the next question on Newton's third law is to hit the subscribe button, okay? Thank you.